I will talk about architectural alignment. Architectural alignment is the problem of designing architecture at the infrastructure application and business level such that each fits optimally with the other architectures. The main goal of enterprise architecture alignment is to derive operational guidelines for aligning IT infrastructure or IT architecture with business architecture. In this regard, we start with defining the word system. We need to know what is a system and what is it we are trying to align. A system is an assembly of components that behaves as a whole. There is a synergy between components, and this synergy results in emergent properties. So interaction between the internal parts of a system creates or resembles the properties of that system. A product is a system with properties that are useful for someone. For example, the system of law, such as a traffic law, comprised of speed limits, traffic lights, other rules and regulations that are useful for the travelers on the road. Another example is the Australian national soccer team. Uses 3-3-4 system. So this is a system used by a team, which is a systematic way of working. So it's a systematic way of working the internal components of this team or of this system that results in some sort of attributes for the outside world. Now that we know what is a system, we try to describe the dimensions of a system. A conceptual framework is a collection of concepts and relations amongst those concepts that can be used to describe a phenomenon. After almost 10-15 years, we used a lot of frameworks in describing IT architecture. The industry came up with a list of different dimensions. Of course, this is a very concentrated list. This list comprised of 3 different dimensions for a system. First is system aspects, which is about the external observable properties of a system. So whatever you see, whatever properties visible from outside the system is called system aspects. System aggregation is the composition of complex systems from similar systems. So it is about the building blocks of a particular system and what is going on inside the system. And finally, the system process is the life cycle of that system from creation to its disposal. Now we go through these in a little more details. System aspect. System aspect is the external observable properties, as we mentioned. An aspect system is the set of all of these elements with only some of their properties, and the subsystem is the subset of these elements, but also with the same properties. We can reduce the complexity of a system model by focusing on an aspect system or ignoring a subsystem. A system offers services to its environment. Quality properties characterizes the value that the system provides for its stakeholders by the services it offers to them. For example, Usability, efficiency, and security are aspects of a value that a system service have for its users of the system. At the other hand, maintainability, portability, and things such as that are aspects of the value of the system for developers of the system. So as you can see, different stakeholders use or are interested on different aspects of the same system. And that gives them the meaning of the system. Therefore, the meaning of the system is different based on the stakeholder. Now we look at the system aggregation. System aggregation is the composition of complex systems from similar systems, or should say similar subsystems. When we study IT architecture alignment, this simple picture becomes more complicated because there are different kind of aggregations. In this image, we can see composite systems, which is about the service behavior, communication, meaning, and the quality of the system. External entities also have these attributes. System itself, external, and also a component. What does it mean to say that a module is combined in a program? If this module may exist in several fragments in several physical places, for example, something that exists in a disk, in a memory, or a cache, and may be used by several programs or subprograms. For example, when we say C is a component of A, what does that really mean? We can look at that from two perspectives. Service provisioning, which we can say C provides a service to A. In other words, C plays a role in the realization of services of A itself. The second way of saying that is when we think about encapsulation. In terms of encapsulation, an external entity, for example, an entity that is not a component of A, can only interact with C through the interface of A. In the physical world, this means that A provides a protective cover for C. In the social world, this means that A is owned by A. The C is owned by A. So that interaction with C is always also an interaction with A, or you can talk to C if you satisfy A first. In the symbolic world of softwares, this means that an interaction with C requires interaction with the interface offered by A to its environment. And finally, the third and last dimension is the system process dimension, which is talking about the life cycle of a system from creation to the disposal or decommission in terms of software. System process is the life cycle of the system from creation to disposal, as we said. This third dimension consists of the stages that a system goes through in its life cycle, from conception to creation to disposal and so on. We can abstract from the complexity of real life by considering each system in its current stage only. So at any given time, you can consider the system However, an important part of alignment problem is the coordination of the future development of a system. So we should be looking at the system in its own entirety throughout its life cycle, not in a snapshot of a time at any given time. So we shouldn't be looking at the system at a snapshot, where instead we should be looking at the system from in its life cycle, in the past, future, and present. So it's a continuous look at the system. This problem is something sometimes complicated because if the system was only one version of the system in place, that would be fine. But for lots of systems, several versions may exist, because many systems are supplied by third-party developers or third-party companies, each with their own release frequency and multiple versions. Coordinating between those different successive versions is a particular problem by itself. Now, considering all these issues, the life cycle of the system, the components, aggregation of the system, and also the system itself, we come up with a list of heuristics for architecture alignment in order to resolve all the issues or problems arising from all these attributes. So, in general, over time, architecture alignment heuristics has been developed by the industry, basically by the industry common practices. This is to increase the probability of finding an easier way to achieve business information and application architecture alignment. Here you can see main heuristics to consider when checking the alignment between business and application architectures. First one is talking about, well, let me read these and then give you a little more explanation for each one. Number one, each business process should be supported by a minimum number of applications. This rule simplifies user interface among applications. It also reduces the need for application integration and also minimizes the number of applications that must be modified when your business process is changing. Number two, business activity should be supported by a single application. So business activities, a bunch of business activities should be supported by a single application. This reduces the need for distributed transactions among multiple applications. Okay, so if one business activity or unit of activity is taken care of by multiple applications, then these multiple applications should be integrated and also in a way that they can communicate while this business activity is being carried out. So to simplify this complexity, it's better to follow the rule of using one single application carrying out a business activity. Three, a critical business process should be supported by scalable and highly available applications. That's pretty self-explanatory. Number four, critical business process or activities should be supported by different applications than the non-critical business process or activities. So we should be distinguishing or completely separating critical applications and non-critical applications, and dedicate totally different sets of applications to take care of critical or non-critical applications in separate ways. This helps to keep critical hardware and permanent maintenance teams as small as possible. Number 5, each application's functionality should support at least one business process activity. Otherwise, it plays no role in supporting the business. And number 6 says that information required for a critical process should be also supported by scalable and highly available systems. This means that critical processes should be supported not only today in a snapshot, but also into the future, because they are critical business processes. These are critical to the business. So to support those and to ensure that there is no disruption to this business process, you need applications or systems that they are scalable and always available. You cannot, if the system goes down, then your critical processes will go down, will stop. That will stop your business. Number 7, business process activities requiring online or batch support should be supported by applications running on different infrastructure. This is to make it easy. The tuning of the systems for operating Windows. Now, there's another list of alignment heuristics for application and information infrastructure or architecture. Let's see what are those. Number 1, an information entity is managed by only one application. This means that entities are identified, created, and used by a single application. It is not a good idea to handle a particular entity, a business entity or an information or data entity, by multiple applications at the same time. Number 2, information entity are created when identifiers are assigned to them, even if at that time no attributes are known. Okay? So you must create the information entity even if you don't know a lot of their attributes. You shouldn't be delaying that. One example of that is if the client information entity may be created before its name and address and other attributes are known. Even so, the application that manages the client information entity must be the application that manages their ID as well. So by creating the entity, you automatically creating an ID. And then what is really important for the system is the ID of that particular business attribute or data attribute or information attribute. Entity, sorry. Now, when you have the ID, then you can work with that, even though the information or the other attributes of that entity is not complete. Point number 3, applications that manage information entities should provide means to make the entity information distributed across the organization using agreed on protocol and formats. Number 4, exporting and distributing information entities across organization application should make use of data stores rather than point-to-point application integration. What we mean here is that if two applications work with one entity, okay, let's say customer, all right, it is not a good idea to one application create a customer entity and do some of the work with that and then hand it over directly to another application to do another work for it. That's a bad design, and it's not a good alignment heuristic. The better way of doing this is that let the first application create and do its work with the business entity or whatever entity, as we explained, say for example the customer, and then store it somewhere in a database or some sort of storage in a file or whatever resource storage center. And then the second application can pick it up from there and do the rest of the work. This point number 5 is very closely related to number 4 as well. It's talking about the application managing a given information entity should export its content into the data store when its content have changed. Okay, so it's the continuation of that. If you change something on an entity, you don't hold on to it and hand it over to somewhere else. You have to be storing it somewhere. And also number 6 again, similarly close to that, is talking about when application requiring given information entity should require the data store for up-to-date information. This allows for computational independence between applications and make possible to size the HV or hardware required to run an application without knowing the rate that the other application demand information for it. And this is how we come to the end of this session. And in this session we explained why is it important to align our information and application infrastructure and information systems with our business architecture. And to do that, we suggested to you a list of heuristics and common good practices in industry.